So most common way to do this supervised relation extraction is, here we need to train binary classifier. So we'll use binary classifier in order to determine whether there is any relation between the entities or not. What we are doing in supervised, in order to find out whether the relation exists between two entities, we need to use binary classifier. So these classifiers usually they take, so here these classifiers they take features about the text as input, and they require the text to be annotated by NLP modules. So what we are doing, we need to provide features about the text. So we need to provide features to the algorithm or the classifier as input. So what can be the features here? The features can be either context words or POS tags, dependency path between entities, NER tags, or tokens, or proximity distance between words. So it can be anything. After providing the features, so here how to train the model. So we can train and extract by, so here we can train and extract by first manually label the text data according to whether a sentence is relevant or not for a specific relation type. So we need to give labels to the text data by finding relevance. So if you take this example, say the relation is CEO relation. Now we need to check whether these sentences are relevant or not. So based on that, we need to provide labels to the sentences. So for coming to the first sentence, Apple CEO Steve Jobs said to Bill Gates. So here in this sentence, relation is CEO. So if you take this Steve Jobs is CEO as well as Bill Gates is also CEO. So relationship between them is CEO. So that is a relevant relationship. Both are CEOs, right? So you can use relationship CEO between these two entities. Whereas coming to second sentence, Bob, pie enthusiast, said to Bill Gates. So here Bob is a pie enthusiast, whereas Bill Gates is CEO. So we can't establish relationship, or we can't use this relation CEO between these two persons. So we can say that this sentence is not a relevant sentence. So like that, we are giving labels to sentences. And so here manually label the relevant sentences as positive or negative if they are expressing the relation. So you can even label the sentences as positive and negative. So if you take the example, Apple CEO Steve Jobs said to Bill Gates, now find out positive label and negative label. So for that, first you need to generate triple from the sentence. So here the triples are CEO Steve Jobs, CEO Apple. So if you take this, yes, CEO is CEO of Apple. So as it is a correct sentence, we can label that sentence as positive. Whereas coming to the second one, Bill Gates, CEO Apple. Bill Gates is not CEO of Apple. So this is a negative example. So in that way, we can assign labels to the sentences based on the relation. Then you can use the binary classifier to determine if a sentence is relevant for a relationship type or not. So in order to check the relevance of words for a relation, for a type of relation, we can use binary classifier. And after that, so after training the model, you can use the classifier to detect relations in the new text data. So this is just like training and testing. So here training was done by using binary classifier. And once the training is done, you need to test the model on the new data. So we are providing new text data and we are using the classifier to detect relation in the new text data. Next method is distantly supervised relation extraction. So here we can combine the idea of using seed data. So seed data is used in weakly supervised relation extraction, right? So we saw this before. So we can combine seed data with training a classifier, the method which we used in supervised relation extraction. So instead of providing set of seed tuples, we can so instead of providing seed tuples ourselves, we can take it from a existing knowledge base. So here we are taking knowledge base. So knowledge base can be Wikipedia, DBpedia, or Wikidata, Freebase, etc. So we are going to extract seed tuples from this knowledge base. So we are not defining them ourselves, just like how we did in case of weakly supervised relation extraction. So first we need to take the data from the knowledge base. So assume that we want news articles. We are concentrated on text corpus which contains news articles and medical papers, pass them to the corpus specific models, and from which we got relation structures. So simply we can say that we extracted tuples from the knowledge base. Assume that these are the tuples. So relation structures are nothing but seed tuples only. So this relation structure as a kind of tuple. And now the process is select sentences from our unlabeled text data that match these tuples. So we already generated tuples. Now you need to take the unlabeled text data. So this is the unlabeled text data and select the sentences. So we need to select only the sentences which match with the tuples which we generated. And assume that all these sentences are positive examples of this relation type. So we need to assume that all these sentences are positive examples only. So what is positive example? What is negative example? We saw that before in the previous slide. So, what will be the positive example? So if I say Steve Jobs, CEO Apple, then that is a positive tuple or positive example. If it is Bill Gates, CEO Apple, tuple, if we take that C tuple, then that is a negative example. So here we are assuming that all sentences are positive sentences only. Now extract features from these sentences. So from the sentences, you need to find out POS tags, or you can extract features like context words, etc. Then we can use supervised classifier in order to determine if the sentence is relevant for the relation type or not. After that, after training, just like how we did in case of supervised relation extraction, you can use a supervised classifier to detect relations in new text data. So this is a combination of previous two models. Simply we can say like that. Coming to the advantages of this model, so less manual effort is required, and so we can use large amount of labeled data and any number of relationships. So this model can be applied for a data set which is having huge amount of data and many relations, and no iterations are required. So as we are combining both the models, weakly supervised and supervised relation extraction, even though there are iterations in weakly supervised, here no need to use any iterations. Coming to the disadvantages, so noisy annotation of training corpus, and here there are no explicit negative examples because we are assuming that all sentences in the unlabeled text are positive examples. And it is completely restricted to knowledge base because we are extracting here because here we are extracting relation structures from knowledge base or C tuples from knowledge base. So this is completely restricted to knowledge base. And while tuning, we need to perform or we need to be very careful And the last one is unsupervised relation extraction. So here we'll extract the relations without providing any labels to the data. So we are not going to provide any set of C tuples or no need to write any rules in order to capture relations in the text. So if you take this one, so here this is the unlabeled text, and from this we are generating different phrases from the text. So here you can see we have noun phrase, verb phrase, adverb phrase, like that. For the words present in this text, we are generating different phrases. And this should be provided as input to the relation generator. So now, next, the same text should be, so from this text, we need to generate dependency parse tree. So here you can see constituents as well as dependency parse tree was generated. Then this should be provided as input to the step 4. So step 4 is relation filtration. So we need to provide dependency parse trees which we generated from this unlabeled text as input to relation filter, as well as the relations which are generated from this phrases that should also be provided. And these are the constraints. So constraints are like this: there exists a dependency chain between E1 and E2 that is no longer than a certain length. So we need to provide some conditions. So all these three things should be provided as input to the relation filter. And what this relation filter will do, it will filter all the relations, and that will be provided to the next step as input. And during this fifth step, we need to find out frequency occurrences. So, how many times a single word appeared in the text? So, if you say this, had occurred 2 times, been occurred 3 times in the text, transferred occur 4 times. Like that, we need to find out number of occurrences of that word in the text. So, that should be provided as input to next step. Next step is feature vectorization. So, this text or this data should be provided as input to the feature vector, and that vector representation of words will be provided as input to the classifier for training.